Okay, so we're going to start off by filling in these two tables and then graphing the two functions individually. So I'm going to go ahead and have you do this on your own, but I want to just point out one thing really quick. Make sure you realize that there's a big difference between this one, which is y equals 2x, and this one, which is y equals 2 to the x power. We're going to talk about exponential functions, where there's a variable as the exponent today, and we're going to kind of look at the differences between a linear function and an exponential function. So just make sure here with 2x, that's like 2 times x. So you're just multiplying 2 times these numbers here. And here on b, it's 2 to the x power. So with the 0 here, it would be 2 to the 0 power. With 1, it would be 2 to the first power. With 2, 2 to the second power, and so on. Okay? So go ahead and pause the video, fill in your tables, graph the two graphs accordingly, and then go ahead and play the video when you're ready. Okay, so zooming in here on A, I just have 2 times the number. So 2 times 0 will be 0. Let me get a different color here. All right, 0. Okay, 2 times 1 will give me 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 3 is 8. Or sorry, 2 times 4 is 8. So then filling in my table here. I know it's not super easy to see, but we can see well enough. So if 0, 0. 1, 2, 2, 4, 3, 6, and 4, 8. So there is my line, and I'll go ahead and graph that. Okay, and we'll talk about in a minute what types of lines these are, okay, or what types of graphs these are. Okay, so there's A. Now let's zoom in on B. And keep in mind here, this is 2 to the x power. So we have, first plugging in a 0, 2 to the 0 power. We know anything to the 0 power is 1. 2 to the first power would be 2. Here for x being 2. 2 to the second power, that's 2 squared, which is 4. And then I have 2 to the third power, so that's 2 times 2 times 2, which is 8. And then 2 to the fourth power, which is 2 times 2 times 2 times 2, which is 16. Okay, so bringing these numbers up here and graphing them. I'm going to have 0, 1, 1, 2, 2, 4, and 4, oh no, I missed 3, 3, 8, and 4, 16. So 16 is going to be way up here off the graph. And you can see my graph doesn't quite form a straight line there. Okay. All right, so now let's talk about this. So let's compare and contrast the two graphs. So the first thing I want you to do is go ahead and pause the video and write down a couple things that you see are the same and different. Okay, so things that are the same. You might be thinking, well, as far as the functions go, there's a 2 in both of them. Both of them are increasing, right? Both of our graphs are going up as we go from left to right. Some things that are different. This first graph here on A is a straight line. It's linear. Okay, that's what. Anytime we have something that is a straight line, we call it linear. And then different on B. Obviously, this is not forming a straight line, right? It's increasing more rapidly, so it's increasing pretty slow here. Speeding up, and then you can see it just kind of takes off. And this is what we call an exponential function, okay? So today we're kind of comparing and contrasting linear functions like we have on A versus exponential functions that kind of grow exponentially, okay? All right, so looking at these questions here, which one is steeper in the beginning? We see that here this graph is growing really, really small in the very beginning, right? This graph is growing pretty much about the same the entire time. So in the beginning, linear is growing quicker, or you could just say A. And then steeper later on, we can see that even though the A, the linear function, stays the same the entire time, we can see that B will gradually overtake it as it kind of skyrockets at the end. So that would be exponential, or B. Okay? All right, so let's fill in our blanks here for linear functions versus exponential functions. So linear functions have an exponent of 0, right? There is no exponent, and form a straight line. that was like line A. Okay, there was no exponent in it, and it forms a straight line. Exponential functions, on the other hand, have a variable. Okay, sometimes x, sometimes t, sometimes different variables, but it has a variable as an exponent, and it forms a, I don't know, some people call I mean, we can just say a curve. You can kind of draw a picture here where it kind of skyrockets like that. Okay, so it starts really close to 0, and it just kind of increases quicker and quicker. That's what the exponential function looks like. Okay, all right, so let's practice kind of graphing some linear and exponential functions on the next page. Okay, so you have a couple practice pieces here. We're just going to do these first two practice pieces, so keep in mind, and I'll give you a little hint here on one. If I am taking the x value of 1 and plugging it in up here, okay, that means I now have 4 times 2 to the first power. So always make sure when you're doing this, you do the exponent part first and then multiply by the front. So 2 to the first power is 2, and then 2 times 4 would be 8. So I would fill in 8 in my box here. Okay, if I was plugging in an x value of 2, then I would have 4 times 2 to the second power. So again, do your exponent stuff first. So 2 squared is 4, and then 4 times 4 is 16. Okay, so go ahead and pause the video, finish out number 1 and graph it, and then go ahead and do number 2 as well and graph it. They might go off the graph, and that's okay. Okay, so just go ahead and do these practice problems 1 and 2, and then play the video when you're ready for the answers. Okay, so we can see from our table here that this is definitely growing exponentially, right? It has a small growth at first, and then you can see it just kind of skyrockets. It takes off. I know it's a little hard to see from the graph because the graph doesn't go up very high, but it will increase at a quicker and quicker rate. Okay, same thing on number 2. If I look down here, you can see going from 1 to 2, it's only a change of 10. Then it goes up 20, then it goes up 40, then it goes up 80. So it's going up kind of quicker and quicker as the numbers increase. And then if I look at the graph again, it's kind of hard to see because our graph doesn't have high enough numbers on it, but it kind of skyrockets and takes off. Okay, so those are just kind of some of the characteristics of an exponential function. It increases more and more as the numbers get bigger, so it doesn't stay at a constant rate like a linear line. It kind of increases at a greater rate. Okay.